So we're going to talk about Git in an hour. There's much more to Git than an hour's worth, but rather than racing through it, I'm going to go through it systematically, and then if we don't get through to the more advanced topics, I will point you at some blogs, or I can come back at some point. There's quite a lot of information out on the internet, but getting a good solid base makes a lot of sense. So let's start at the very beginning, which is what is Git? Git is a version control system, and if you haven't used a version control system the way I imagine it and the way I used to do it, is to program for a while and then make a complete backup of your folders all the way down, and then program a little bit more, and then make another backup. And you can continue to do that, and then if you run into a problem, you can restore from one of those backups. A version control system does that for you in a great deal more, in a great deal less space. But the huge advantages to it are, in addition to being able to go back to a safe or working version, you can work on one feature, and then if you need abruptly to go to another or to go fix a bug, you can switch among them without losing your work very quickly, very easy. And also, if you're working on a team, it becomes much easier to share code. One key thing to remember about Git is that virtually everything happens locally. That's very hard to keep in your mind because it feels like a lot of it is happening in the cloud. You'll know when you're sending something to the cloud or taking it from, but the vast majority of what you do will happen right on your disk. And the other nice thing about Git is that you have to work pretty hard to lose any work. It's a very safe system, and even if you do appear to lose work, you can almost always recover. So there are certain areas that we think of in Git, and I'm just going to go through them quickly and then in a bit more detail. There is what we call the work area, the index, and the local repository. Then there's a repository that's remote and a stash, and let's go through those one by one. The work area is the current files on your disk in your working directory. So if you open up Visual Studio or whatever IDE you're using, these are the files you'll see. Now Git will swap out under your direction other files into your working directory. You'll always have only one work area, and that always has only one version of your program. The staging area is where you put files that you want to commit, and commit means to put those files into the repository that is on your machine. The repository is responsible for holding all the versions of your program. And it does that in a hidden directory, .git. You can, if you have hidden directory showing, you can certainly look in that directory. The one thing you don't want to do with Git is to touch anything in that directory. That's a surefire way to lose work. The remote repository is a mirror of your local repository and the local repositories of other folks who are on your team. This is where GitHub comes in, or Azure. So the remote repository is just like any other repository, except that it's in the cloud. One of the nice things about Git is if that remote repository were to be destroyed, it can easily be recreated off of any of the local repositories. The stash is a place to hold some modifications. If you're in the middle of something, you're not ready to commit those files, but you don't want to lose them, you can put them in the stash. There are a number of ways to interact with Git. Many people like to use a GUI. Some of the big ones are Fork, GitHub for Desktop. There's a couple of source tree, a few of them, and many of them look like this. They give you a visual picture of the development of your project and who has checked in what, and how the branches, which we're going to discuss all these terms as we go. If you use Visual Studio 2019, there is now a great deal of support for Git built in to Visual Studio itself. Virtually everything you can do at the command line, you can do right in Visual Studio. The command line, however, is the is the canonical way to work with Git. Anything that you want to do with Git can be done with the command line, and some of the GUIs, virtually all of the GUIs, have some limitations. Whereas the command line, if it can be done in Git, it can be done at the command line. I like to use this nice looking, pretty command line. Excuse me. And you do that by installing PowerShell. And then if you want to have this, which shows you where you are and what the status is of your current branch, and it will have, you'll see as we go, it'll have indicators for when you have new material, when you have added material, when you've deleted material. If you want to do that, there are just 2 steps: install PowerShell, and then go to this link. And I'll be making these slides available so you don't have to write this down furiously, where Scott Hanselman has an article on setting this up. I seem to be losing my voice. It's going to be a perfect evening. Okay, let's begin by creating a repository. There are a number of ways to do that. You can do it locally, or you can start remotely. Let's start remotely by going to GitHub, which is, I believe, if not the most popular, certainly one of the most popular places for a repository. So let's just say github.com. Now I'm already signed up and logged in, so it's brought me to an overview page. I'm going to click New, and that indicates that I want to create a new repository. So we're going to say that we want to give it a name. Let's call it .NET North. Is that a good name for you folks? Hope so. We're going to put in a description typically to say what the repository is for. And then you can make your repository either public or private. And we're going to make it public so that it's available to you after we're done. I strongly recommend that you always add a README file. They will generate for you just a blank README file with the name of your repository, but you'll want to update that so that it tells a user coming across your repository what it is and perhaps how to get to what they need. Git ignore is almost essential. It says, here are the extensions and the kinds of files I don't want in the repository. And that keeps your repository from getting cluttered, and it also prevents overwriting other people's setup. So we'll say add git ignore, and then you pick your language, and there are just a ton of different languages. C# is not one of them, but you can enter Visual Studio, and that will give you all of the items that you want to ignore for Visual Studio and also for C#. I don't know how many of you are C# programmers, .NET programmers. Much of the code that I'll be demonstrating is very, very simple C#. The next thing we want to do is to choose a license, and you can be as restrictive as you like. I'll use the MIT license because I know that it's very non-restrictive. And then if you want, you can set up hooks into Slack so that GitHub can notify you through Slack as things are added and so forth. I'm not going to do that, but I am going to create the repository. Now, what it has done is it has created a repository on GitHub. It hasn't done anything on my disk yet. And it has the things that we asked it to add, the git ignore file, the MIT license, and a README, which is shown here. The next thing I want to do is get this repository onto my local machine. And for that, I'm going to come over here, and you can see the little download symbol, drop it down. And I do want to clone. Most of the time, you'll clone with HTTPS. I'm set up with SSH, and so I'm going to use that. You can also clone directly to GitHub Desktop, which is a GUI. You can download all of the file as a zip file, but we want to clone this repository so we have one locally. So I'll just copy that, and then I will bring up my command line, and I will say git clone, and then paste in what I just copied from GitHub. And it's going to clone it into a folder, .NET North. Okay, so I'm in that, and I'm in the main branch. We're going to talk about branches, but I want to keep that main branch clean, so we're going to talk about how to do that as well. Notice that there is now a getignore, a license, and a readme, just as there was on the remote. So they are now synced up. The first thing you're almost certainly going to want to do is to put some code in there to get started with a program, whatever you're working on. So I'm going to go ahead and open up Visual Studio and say to create a new project. Where am I? New project. And to keep life simple, we'll use a console application. We're going to call this .NET North. I recommend that your project name and your repository name be the same. It makes life much easier. Let's go find where that is. I believe I put that in GitHub. And then .NET North. And there you see the Get hidden directory, by the way. Feel free to look at that. Once you've set up a repository, we'll select that folder. So now it's going to put it where we want to have it. And I will say, go ahead and create it. And it comes up in Visual Studio, I hope. Where did Visual Studio go? There it is. And it just creates this very basic program for you. Okay. When you want to go from the work area to the staging area, you use the add command. When you want to go from the staging area to the repo, that is the repository on your machine, you use the commit command. Now, commit is used in two ways. You commit files to the repository, and then we talk about commits in the repository. So every time you commit to the repository, you create a commit in the repository, which can get a little confusing until you get used to the terminology. If you're going to try to get the data that's on your local repository up to your remote repository, then you want to use push. And you're pushing that data up to the remote repository. When you commit, you'll be asked to put in a message. Typically, you'll want to put those messages into the imperative, although I have to say that while great in theory, in practice, many people just don't. You forget, you say, I added this or I fixed that, as opposed to saying add or fix. However, you do want to be careful that your message says something meaningful. So you don't want to just say I added some files, but you want to explain what you added so that when you're looking at dozens of these commits, they're going to make sense to you. If your commits don't work out, or you add them and then later regret it, you can fix that with an interactive rebase, and we're going to look at that as well. Okay, we created main. Pointing at main is head. Head simply says, here's where you are in your repository. Typically, we don't want to add any code into the main branch. Instead, we want to create a feature branch. All development is typically done on feature branches, and you will have often many feature branches, and then you will add them back into main, and we'll look at how to do that. So let's go back to our repository, and we're going to say get checkout -b, and this is really a shortcut. You could say get branch and give it a name. And then check it out. Okay, let me try that again in English and a little slower. You can say get branch, and then let's call this calculator. And then you can say that you want to go to that branch. Notice you're still on main. So you could say get checkout calculator. And now you'll notice that you are on the calculator branch. Now, the shorthand for this, which is where I started to go, is you can say get checkout -b calculator, and that will create the calculator branch and will also check it out. Okay, the way to look at this is that you have one file added, no files modified, and no files deleted. So let's see what that one file added is by using status. Get status. And we see that the entire folder, .NET North, is waiting to be added. It's not tracked. Notice it's under untracked files. It's not yet part of our repository. So we're going to say get add. And that just added it to the repository. So if I say get status, it tells me that I have 3 files, which is just what you would expect. And here we see it says +3. We're now ready to commit those files because they're in the waiting area, in the index. So if I say get commit, it's going to take everything that's in the index and commit it. Now it wants a message. So it opens up my editor, and I'll call this initial commit of calculator class. And then when I save this and exit, it will take that message and add it to the commit. And should have brought this back up. Didn't, but that's all right. And that's not where I want to be at all. Hang on. That's my actual work one. Well, okay, we can get back. Not quite sure why it did that. Okay, here we are. Very interesting. It did not commit them. I'm not really sure why. Another way to get the message in is to say -m, add calculator. Okay, this time it did work. 3 files were added into the repository, and you can see calculator now is green and has no numbers, so it is clean, and these are now committed. Now remember, they're committed, but if we go up to our repository, they're not there. Even if I refresh, they're not there because we committed them to our local repository. If we want them to be up in GitHub, which is a good idea both for getting them off site and also for being able to share them with others, then we're going to say get push. And it's going to say, I don't know anything about your calculator up on GitHub. So the first time you push any branch, you have to use a special command, and fortunately Git prints it out for you. So I'm just going to grab this, copy it, paste it, and push it up. From now on, I'll just be able to say git push when I'm on this branch. If we now go back to GitHub and look at our project and update it, you can see that we now have that it tells us the calculator had recent pushes, but we don't see it. And the reason we don't see it is because we're on main. We now have a branch called calculator. When we go to that branch, suddenly we do have a folder .NET North. Inside that folder is the solution. Inside the project folder, we see program CS, and we can even dive all the way into the code. Let's go back out a bit and return to our slides. Notice because we have gone off onto feature 1 and checked it out, that head is now pointing to the tip that is the latest of feature 1. As I make more check-ins to feature 1, more commits, It's indicated in a diagram like this. This was my first commit. My second commit, and notice the arrow points to the first commit. The second commit has everything in it that the first commit had until you change it and commit it. Then I do some more work, make some more changes and commit it, and it goes to the next commit. Meanwhile, main has had changes, not having to do with us, but other programmers have modified main, which we'll look at. But our feature one is still pointing to the first check-in or the first commit on the main branch. If we wanted to open up another branch, let's say we were working on a feature, but suddenly we needed to work on a bug, or somebody else wanted to open a second feature, the first thing we would do is check out main. So we're starting in main. And then we would say get branch feature 2. You saw that a moment ago. And it's going to branch off the tip of main. And since we've just checked out feature 2, head is pointing to feature 2. But this is hard to do without being able to see you. I can't tell if you're glued to this or you wish it went faster or slower. I'm just going to assume you're standing and cheering. If we do checkout on feature 1, the only thing that's going to happen is head is going to go from pointing at feature 2 to pointing at feature 1. Once we've finished our work on feature 1 and we want to add it back to main, there are a few ways to do that. The traditional way is to do a merge. However, if you're working with other people on a project, you probably don't want everybody merging willy-nilly back into main, because main is the branch that you're going to want to create your distribution program from. So most teams put in what's called the need for a pull request. Pull request says, please review my code, and if it's acceptable, please add it to main. And you'll hear the term pull request throughout the industry. It's a way to keep your main branch clean and make sure that at least one other person, and some people set it up so you have to have 2 other people approve the pull request. So if you want to go from the repository on your machine to the remote repository, you push. Now, if you want to go and get another branch, you want to check that out, the first thing that you do is you pull it from the remote branch into your machine. And then, now that it's in the repository on your machine, you can check it out, and that'll put it into your work area. And if you look at Visual Studio after you do so, your code will be different because you've now checked out a different branch. In the case that we're looking at here, you can see that main is pointing to the tip of main. Head and feature 1 are pointing to the tip of feature 1. If I want to merge these, notice that there's a path that I can follow all the way up to feature 1 without losing any of the check-ins, of any of the commits. Try that again. If I do what's called a fast forward merge, and this will happen automatically for you when you merge, Get is going to look and say, oh, there's a direct path from one to the other. All I have to do is point the head and feature 1 and main all to the tip of feature 1. And now it's merged in the sense that it's part of the main branch, but this is more or less on top of the main branch. And your features have now been made part of the main branch. What do you do, however, if main has changed since feature 1 was created? Notice that feature 1 is now pointing to a middle commit of main. At this point, you cannot do a fast forward. There are a couple ways that you can resolve that. The traditional way is to do what's called a true merge. A true merge is a new commit that merges the 2 branches together. An alternative to that is a rebase. Now, if you've been around people who use Git, rebase has one of 2 reactions. Either the person blanches and goes running from the room, or they rub their hands together and say, yes, rebase. But rebase is actually fairly straightforward. It simply says, right now I'm pointing to the wrong commit on this branch. So I'm going to now tell get to point me to the tip of main. And the way it does that is it makes a copy of each of your commits and creates essentially a new tree where it points to the tip of main. And you can see the commands to do that. Typically, what I recommend is that you change to main. So you check out main and then do a pull to make sure you have the latest commits from main. Then check out feature one and say get rebase main. And that will rebase feature one onto the tip of main. It's typically drawn like this. You can see that they're really just the same, that you can track from the first check-in of main all the way up to the last of feature one. But rebases are generally drawn like this to indicate that you have rebased feature one onto main. A merge is a merge into main. A rebase is essentially a merge onto main, onto the tip of main. Rebasing has a number of advantages when you're looking at the history of your entire project. You have far fewer check-ins, far fewer commits that are just for merging. It also can help you reduce conflicts by taking commits and rebasing them frequently. But the key thing and the most dangerous thing is to never rebase on the server. Once your code is on the server, it's essentially shared with other people. And rebasing, you'll remember, changes the history of feature one. It makes copies of each of the commits and puts them on the main branch. If someone were working on a feature or on main or on feature one, and then you were to rebase, you would change things out from under them. So the rule is to never rebase on the server. You do all of your rebasing locally, and then when you are ready, you check out that feature and you merge it into main with all of the rebasing already accomplished. A key thing to remember if you're going to rebase is not to do a pull after the rebase. You might and would do a pull on main before the rebase. But once you rebase, and if you can hear my dog, I apologize to you. We all have the fun of working at home right now. Instead of pulling after you rebase, you do a push, and you want to do a push force, which says essentially, I know what I'm doing. I have the code that I want here locally. I want to force it up to the server, to the main branch on the remote. However, that has the danger of overwriting someone else's commits. So I recommend that you always add with lease, which you do with dash dash with dash lease. And that tells Git that if it's going to overwrite anyone else's commits, to just fail. So the order of operations for rebasing is change to main, pull main to get the latest, change back to your feature branch, rebase, and then if you're done, force with lease on a push. There's another kind of rebase called an interactive rebase. It's unfortunate that it has the same name because it really is a completely different thing. Rebasing allows you to say, before you put them up on the server, here are a number of commits. I want them to appear as one. I did a little work and committed. I did a little more and committed. I did a little more and committed, and realized that all three of them really should look like one. So I would use interactive rebase. It also allows me to reword the messages that I've attached to them, to remove commits, and to reorder commits. Let's take a look at a diagram that shows that, and then let's take a look at a demo of how to do all of this. So here we have a test branch, and it says that I have 4 to upload. I call get rebase -i or -i, which is what makes it interactive. I do all of the interactive work, which I'm going to show you in a moment, squashing 3 of my commits into the first, and now I have only 1 commit to put up. Let's do a little bit of code to make this a little bit clearer. If we go back to our calculator, we're going to go ahead and add a calculator file. So I'll say add class, and I'm going to say calculator. Now I have my new class calculator, and I'll make it public. And normally I would do all my work in my calculator, or a lot of my work in my calculator, before committing. But for purposes of demo, I'm going to be committing a lot. So let's save that and come back down to our console. And the first thing we're going to do is get a status. And it tells us that we have a new untracked file. So I'm going to copy that name. And I'm going to come down here and say get add and put that name in. And that adds it into the staging area. And now I can commit it. Create calculator class. And that file is now in my repository, and you can see that I have 1 to push, but I don't have to push. I've made a commitment, but I don't have to push that commit up. Let's make another change here. We'll add a first function returns int. I'm doing very well today. Int add takes 2 parameters. And it's going to return left plus right. Okay, that's our basic first method for calculator. I'll save that, come down here and say get a status. And notice now that it is part of get. I don't have to go through that first step of trying to add it, and it's telling me that it's been modified. There are a couple of things I can do right now. I can add it and then commit it, or I can say get commit -a, which is going to combine adding it and committing it. And notice they tell you here, get commit -a, and then I'm going to say -m for my message, add method. And that committed it as well. Now we're going to talk about log and a number of other functions to keep track of where you're up to. But if we do a get log right now, we see that we've got a number of commits. Some of them are up on origin or main. I'm sorry, origin is the universal name, unless you change it, for your remote repository. And in main, we had initial commit, and then we created the calculator class, add calculator, and so forth. But right now, we have these 2 commits that have not been pushed. And you can see that right here, 2 to push. I'm going to do one more. And we'll call this subtract. And we'll just make this left minus right. Save that. And I'm going to commit that. I tend to take a status every time just to make sure things are where I think they are. And this information over here is telling me, because it's in yellow, that something has changed. I have 2 that have been not pushed yet, and I have no additional files. I have 1 modified file and no deleted files. So I'm going to say get okay, I've now made 3 commits, but they're really all about the same thing. They're all about creating a calculator class. I could just push them up, and then my history would show them each individually. But I really don't want to do that because I want a history that's easy to read so that team members can see what's going on, so that when I come back, I don't have to slog my way through all these extra commits. So I'm going to say get rebase minus I to make it an interactive rebase. And then I need to tell it how many commits I care about. So I'm going to use head, which you've seen before, and I'm going to tell it how far back to go. I know I want 3 of them, so I'm going to say 4 to make sure. And it's going to open my editor and show me the last 4 commits. And they are in the reverse order. So my oldest one is add the calculator class, create the calculator class, add the add method, add the subtract method. I want to squash these final 2 into the one above. So I just go over here where it says pick. Pick just means add it to the, add it as another commit. I'm going to put in S for squish, probably actually squash. It's right here. I always call it squish. And then we'll squash that one. And this says squash these 2 into this calculator class. So I will save that and exit, and get will say, okay, I need your editor to tell me what you want in the messages. And I'm going to say that I want create the calculator class with add and subtract. Don't have to do it this way, and get rid of the other messages because now they are redundant. And save that. Close it. And now I only have 1 that has not been pushed. I had 3, but I squashed 2 of them into the first, and so I have only 1, and I can say get push. And that will push that 1 commit that contains the others. And that will all go up to GitHub. And you can see now what was going on in that diagram. The important thing to remember about interactive rebases is that you do the interactive rebase before you push your code up to the server, to the remote repository. And that's true for rebase and interactive rebase. Here's an approximate order of operations. You're going to create your branch, write some code. When you come to a logical place where you've written a chunk of code, you're going to commit it, then repeat those 2 steps. Periodically, you're going to do an interactive rebase to keep everything clean. Periodically, you're going to do a rebase, not interactive, a regular rebase from main into your branch to make sure that you don't have any conflicts. And then when you're ready to go and put this on the remote, you're going to pull main, rebase onto main, do that as many times as you need to as you go along. And when you're ready, you're going to push using force with lease. Then you're ready to do a pull request, and the other members of your team can review what you've done and merge that into main. Okay, a few incidental pieces to look at. We have about 12 minutes if I'm looking at this correctly, so we'll look at some of these a little quickly, and we probably won't get through all of them. The first thing is that you can use aliases, and I use aliases a lot. In fact, so much that it was almost painful typing everything out when we were going through that today. An alias is very straightforward to create. You say git config. If you want this to be global, which you almost certainly do, you add -- global, and then the keyword alias and a dot. After the dot comes the alias itself. So here I've made an alias CO, and then the command you want that to represent, which in this case was checkout. One that I use more frequently is alias. I'm creating an alias BC, which calls checkout -B. In other words, create a branch and check it out. That's why I call it BC. but these can get quite large. Here's one of my favorites. And again, you'll have the slides. Don't try to write this down. This comes along and says, I want to add some colors into an alias of my log. So I have get config. I want to make it global. Here's my keyword alias LG. Then the command log and any parameters. There is a word for what comes after this. I've totally blocked it. And then all of this. And the result of that, I'll show you by going here, is if I take a log, if I just take a regular log, get log, it looks like this. It's got the information I want. It's got the commit, tells me where, it's got who wrote it, it's got the date, and it's got the message, but it takes up a lot of room, and it can be, with a lot of these, overwhelming and hard to really understand. By using the alias get LG, I get a much cleaner representation of all the same information, even a little bit more. Rather than telling me the date and time, it tells me how long ago it was. So that's part of the power of using an alias. And we saw the difference between the longer commit and the prettier commit. Log. You can actually edit the file that all of this is going into by saying get config edit global. And I'll just show you that very quickly. If I say get config -- edit -- global, it's going to go and find the file that is used for configuration, for global configuration, and let me edit it directly. And so it opens my editor, and here is that file. And here are the aliases that I use. I can also in here say that if I'm merging, rather than using the built-in merge, which I find somewhat tedious to use, I can tell it what I want my merge tool to be. In my case, kdiff3, and I tell it where that is. kdiff3 is a wonderful merge tool. It's very powerful. And so I can just say get merge tool, and it will bring up kdiff3. Hello, I closed the file. What's your problem? Nothing is ever easy. Close. There we go. Okay. Because I find it concerning that I might push force without writing with lease, I've made an alias for myself, push F. And that calls push and with force with lease. So you can see aliases can be very useful. Okay, we've looked at the log some. The log is very powerful, and it takes many flags that give you a great deal of flexibility. So get log one line. I should find a way to keep, I'll show you what, will not be quite as pretty, but we'll be able to keep both up at the same time instead of switching back and forth. Okay, so the first one we looked at is get log one line. So if I say get log, you'll remember I get all of that. But if I say get log -- one - line, oh, there's no dash between one line, then I just get one line per entry. So it's not quite as pretty as the one that I showed before, but it is pretty straightforward, gives you what you're looking for. Let's skip down to some of the other log. There's name only. If I say get log -- name, and this time I do have a dash between the words, then I just get the names of the files that are in that commit. So that's added information. That's very useful. -p will tell me what's changed. There are a number of ways to find out what has changed. The one I mostly use is get diff, D-I-F-F. And if we were to come in here and add a multiply, Save that, and then come back to the command line. Let's clear to make it easier to see. If I say get diff, it's going to show me which lines were added, and if any were subtracted, were removed, they would be in red with minus symbols in front of them, and so forth. So this gives me a context for what changed in this file. And if I change multiple files, it'll list them one after the other. Where have you gone? Okay. I can search for a word by doing --s followed immediately by the word I'm searching for. I can look for everything that has a committer with a specific person. And I can look for everything that has an author with a specific person. And in both cases, I can use the since and then virtually any reasonable statement for how long back you want to go. So this would say, find me and log, display anything where the author is Jesse that was created in the last week. Take this out of the way. Okay, very important command. If you make a number of changes and they are staged, and you realize that one of them, you don't want the changes that you made, they don't even have to be staged. They could just be in your work area. And you want to go back to on that file as if you hadn't edited it. You can say get restore, and if they're staged, -- staged, and then the name of the file. And that's very powerful. Let's take a very quick look at that. If I come in here and I make a divide, this will be integer division. And I come down here and I say get status. And I say, boy, I modified the calculator class. I'm not sure I meant to do that. What did I do? And I go and I say get diff. And I look at what I did and I'm not happy with what I did. So I want to go back to the way it was. So I'm going to say get restore and then the name of the file, which is right here, .NET North, calculator.cs. That's the file that changed. Actually, probably easiest is where it says modified. Let's pick up these, copy, and we'll paste it right here. And now I'm saying to restore this to its state before I changed it. Now, if I go back to my code, boom, those changes are gone. I love when it happens right in front of you. You can use the -- staged if your file has already been staged. You use the -a to get it into the index staging area. So now you're going to use -- stage to take it out, or you can use it without, as we did, with just a file name. And that discards all of the changes. Now, if you use -- staged, all it does is it undoes the addition to the index, but it doesn't change the file. If you use it with just the file name as we did, it will lose all of the changes you made since the last commit. Git show shows you everything that has changed in the all of the non-committed code, and that is very similar to get diff, but git show followed by a hash, and I'll show you how to get that, shows what's in that commit. So if we go back to our command line and we say, and that's not the command line, is it? Here we go. And we say get LG. Okay, we've got a few commits here, and now I want to see what's in this commit. I'm going to say get show and then F026A71, which is the short form of the SHA. And I'm going to go ahead and enter that, and it's going to show me everything that was changed in that particular file, in that particular commit, excuse me. And it'll show me multiple files, whatever was in that commit. Okay, we're coming up on, for me, 4 o'clock, which means 9 o'clock for you. So I'm going to stop there and see if there were questions. And hopefully you found that useful. And, oh, I did promise to tell you about other places where you can get additional information. One place is on my blog, which is jesseliberty.com. You can also, when you do a global search, excuse me, when you do a Google search for get commands, there are a couple different kinds of responses you get. Let's open this up. If I say get, here it came up, push force release. Okay, it's going to come up with a good short definition, and then it's going to offer me the official documentation and then some blogs that talk about how it works. And sometimes you'll find the blogs much easier to understand, but if you like a precise documentation, this will come up and it will tell you description of the command and then the options you can string onto that command. And if you're extremely patient, sometime early this summer, I will have a book coming out on get that shows you how to do get with the command line, Visual Studio, a GUI, and so forth. But that won't be out till early summer, so you may not want to wait.